So on these problems, we are looking to solve given equations, and we're looking for the period in which they are found. So sine has a period of 2 pi. Is 2 pi, so we're going to find in a complete cycle, we're going to find it from 0 to 2 pi. So when we look at the sine of the square root of 3 over 2, we're looking to our unit circle. That is one of our terminal values. And we're trying to figure out what we will find for the angle of those. So when we look at the sine, we're looking at the y values. And because it's positive, we know that sine is positive in quadrant 1 and sine is positive in quadrant 2. So here we're going to find that our theta can equal the square root of 3 over 2 is going to be theta equals pi over 3, and theta equals 2 pi over 3. So in our unit circle from 0 to 2 pi, we find that our theta is equal to pi over 3, and theta equals 2 pi over 3. So that's in our unit circle. But we can also look at all solutions because it says to solve it. It doesn't say we only have to do it in that, but we find our angles first. So for all solutions, that means we're going all the way around again. So we're looking at coterminal angles. So in this case, we would have theta equals pi over 3 plus 2k pi, because that's 2 times pi and then times however many times around we want to go. And then we would have theta equals 2 pi over 3 plus 2k pi again, because we can go around our unit circle over and over. And of course, this would be k is any integer. Now, the second problem we're looking at is we are looking at solving or finding all the solutions of the given equation, and we want to find the solutions in the interval of 0 to 2 pi. So looking at this problem, we're doing basically the same thing, except we're going to take it a step further. So here we have 2 times cosine of 3 theta is equal to 1. Now we need to remember also that cosine has a period of 2 pi. So it's also going to run from 0 to 2 pi. So first of all, we've got to narrow this down. So we're going to start out by dividing by 2 so that we get cosine of 3 theta is equal to 1/2, because we need to get it down to what our angle is. Where cosine is equal to 1/2, we go back to our unit circle. It's positive, so we know we're going to be in quadrant 1 and quadrant 4, because that's where cosine is positive, because our x values are positive. So where cosine, which is our x value, is equal to 1/2, we're going to see, again, we're at pi over 3. And going down, we're going to be at 5 pi over 3. It just happens to be that we end up with the pi over 3's again. Not all problems are going to have it be equal to pi over 3. So we're going to find that 3 theta is equal to pi over 3, and 3 theta is equal to 5 pi over 3 in our interval of 0 to 2 pi. So if we're looking at all solutions, then we're looking at 3 theta is equal to pi over 3 plus 2k pi, and 3 theta is equal to 5 pi over 3 plus 2k pi. Now, this is 3 theta. We really don't want to know 3 theta. We want to know what theta is. So how do we do that? We're just going to divide by 3 on every term, on both of them. Well, this is going to get us theta is equal to, we don't divide by fractions, because this would actually be 3 over 1. We multiply by reciprocals. So this would actually, we'd flip it over, and we're going to get pi over 3 times 3, which is going to be pi over 9, plus 2k pi over 3. And this is going to get us theta. This again is going to flip over. So we're going to get 5 pi over 9 plus 2k pi over 3. So this would be all solutions. And again, k is any integer. Just as it was before. K is any integer. Now, the difference here is we need to find all the solutions. We need to find the solutions in the interval of 0 to 2 pi. So with this, we want to find what solutions do we have specifically in that interval. So if we're going from 0 to 2 pi, what we need to do is figure out, we've got a denominator here of 9, and we want to figure out what can our 2 pi equal if we're looking at pi over 9. So in this case, we're going to take our 2 pi and we're going to change it to the denominator of over 9. So 0 divided by 9 is still going to be 0. And 2 pi, if we're trying to get it over 9, we're going to still have the pi. So this was over 1, so 1 times 9 gets us 9, 2 times 9 gets us 18. So we're looking at going up to 18 pi over 9. Once we reach anything that gets to 18 pi over 9 without going over, we're going to be done, because if we go over that, we're out of our unit circle. So we're going to take each part of this and we are going to solve it for the unit circle part. So we're going to pick values of k and plug them in. The first thing I want to do is I want to get a common denominator on each of these, because that will make it easier to do the process. So here with 9 and 3, our common denominator will be 9. So theta will equal pi over 9 plus, I want to get this to 9, so I'm multiplying by 3, so I multiply the top by 3. So 6k pi over 9. And this one will become theta is equal to 5 pi over 9 plus 6k pi over 9. That way we've got common denominators. It'll make it easier as we add. All right, so the first thing we need to do is select values for k. So on the first one, we're going to do k is equal to 0. So we've got theta is equal to pi over 9 plus 6 times 0 times pi over 9. Well, anything times 0 goes away. So this is just going to get us pi over 9. The second one, we're going to get theta is equal to 5 pi over 9 plus 6 times 0 pi over 9. Again, that's 0, so it's going to go away, and we will end up with 5 pi over 9. Now we're looking at k is equal to 1. So when k equals 1, we're going to get pi over 9. So again, this is our theta equals pi over 9 plus 6 times 1 pi over 9. So 1 plus 6 is going to get us 7 pi over 9. Over here, we're going to get theta is equal to 5 pi over 9 plus 6 times 1 pi over 9. So 5 plus 6 will get us 11 pi over 9. Well, we're still not very close to 18, so let's see if we can do some more. So if we do k is equal to 2, we get theta is equal to pi over 9 plus 6 times 2 pi over 9. Well, that's 1 pi plus 6 times 2 is 12. So 12 plus 1 is 13 pi over 9. And over here we get theta is equal to 5 pi over 9 plus 6 times 2 pi over 9. So that again is 12 plus 5 is 17 pi over 9. Well, 17 pi over 9 is really close to 18 pi over 9. If I tried to go any further, I would end up over my limit. So this is the end of my possible solutions. So in the end, you could state that theta will be equal to, in that interval of 0 to 2 pi, is going to be pi over 9, 7 pi over 9, 5 pi over 9. We'll put it in numerical order. 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9 in the interval of 0 to 2 pi. So we ended up with 6 angles that will work for our interval equaling 3 times theta is equal to 1/2.